We're live.
So hello, welcome Steve Millidge back after the industry keynote. So my question is, have you managed to pass all the certification tests, Jakarta specification, in between, or you still need some time?
We still need some time. They take quite a while to run.
So okay, then the conference takes another 8 hours, so let's see what happens, until, okay. So you are the founder of Payara, actually. So we already had a chat. So I guess it was the very first commit from you to Payara, right?
I think so.
So perfect. So now let's talk a little bit about concurrency and Jakarta E.
Okay. Is that over to me?
Yes, and I will fade out.
Okay. All right. So this presentation is really looking at Jakarta concurrency, present and future. So I'm Steve Millidge, as Adam says. I'm the founder of Payara, and maybe I did the first commit, maybe I didn't. And I'm also, for my sins, the project lead for the concurrency utilities within E4J and JakartaOne. Sorry, not JakartaOne, Jakarta EE, which is why I drew this straw to do this presentation. So what I'm going to do is I'm going to basically look at why do we need Jakarta concurrency? What are the main components of Jakarta concurrency? It's quite a small specification. And then I'll look at some ideas that perhaps we can do in the future. Obviously now Jakarta EE8 is released, then we need to turn our minds to what happens with Jakarta concurrency going forward. And there are a number of ideas floating around. A lot of them have been sort of culled from the GitHub issues. And also just ideas that we've had under discussion. But this is all really early days, and then we'll talk a little bit about how you can get involved with the Jakarta concurrency and generally in Jakarta EE, how we need to move it forward now. Obviously today is a momentous day, and we've got Jakarta EE8 released, and I was heavily involved in getting Jakarta EE8 concurrency released, which is a lot of busy work around Eclipse, Jenkins jobs, and running it through test suites and those sort of things. And now that busy work's over, we need to turn to what we do next. So why do we need Jakarta concurrency? And this will also cover a little bit of review of what Java EE concurrency utilities covered. So what is Jakarta concurrency? So effectively, this is a project and specification name for what used to be called JSR 236, which was concurrency utilities for Java EE, which is not a very sexy name. But it came in Java E7, so it's quite late. There's probably many Java EE applications out there that don't use it at all. It wasn't updated in Java EE8, and in following the rules of what Jakarta EE8 is, there's no change in Jakarta EE8 either, other than the Maven coordinates. So the purpose of Jakarta EE8 was to release something that was effectively binary compatible with Java EE8. So no changes were allowed to APIs when we went from Java EE8 to Jakarta EE8. And that's similar to concurrency. So the only thing that has changed is we've up-revved the version number to 1.1.2, and the Maven coordinates are changed to have the Jakarta namespace. So previously it was JAVX Enterprise Concurrent, now it's Jakarta Enterprise Concurrent, and the artifact for the API is Jakarta Enterprise Concurrent API. So most people won't use these because you'll use a bill of materials and just pull in the full Jakarta EE8 Maven dependency, similar as you would do with Java EE8, but it has moved if you need to do anything with it specifically, or you want to develop on it. Okay, so just summarizing where we are now. So what was the goal of the original Java EE8 specification? So this is actually coming straight out of the spec. So first goal is to utilize existing applicable Java EE platform services. So that's a big word to say that, if we're spawning threads, or we're not allowed to spawn threads in Java EE application server, if we need to, then we need to be integrated with other Java EE platform services. So that would be JNDI, transactions, security, being able to call EJBs, be able to, use CDI beans as well. And related to that, we obviously want the specification is trying to provide a simple, flexible API that you can use normal concurrency design. And the API mirrors the equivalent Java SE API. So the second goal was to allow Java SE developers a simple migration path. So because it mirrors the SE API with managed executors and managed scheduled executors, you use them in the same way as you would in a SE platform, but you get all the benefits of Java EE or Jakarta EE from the first point. The second one was to provide component providers, and that's the people who basically create applications, so EA files, WAR files, so you can easily add concurrency to your existing applications. And therefore it supports very simple, common, and advanced concurrency patterns. Because it's effectively built on Java SE, then it's very familiar from a Java SE world. Okay, so what is a use case? So this is a simple one, or a complicated one, depending on your point of view. So prior to Jakarta Concurrency or Java EE Concurrency, if you wanted to add an asynchronous break in your application, so for example, if you had a e-commerce system and it needs to generate a list of orders or something, and that's going to take a period of time, and then that needs to be emailed off or something, and you don't want the user to be sat there waiting for the HTTP request to finish, then prior to Jakarta Concurrency, then the only way to do this was for your servlet or JAX-RS or whatever, EJB, was to push this through a JMS queue. So many old Java EE applications do this, and many old Java EE applications that I provided consultancy for back in the day when I was a consultant used to purely use a JMS broker just to provide an asynchronous break. So if they needed to generate a port, the servlet would, or the JSP or whatever your application would basically queue a message onto a JMS queue, defining the details of the report you needed to generate, all the information, and return to the user to say, please wait, or your report will be sent later. And then an MDB would pick that up, run some long-running action to generate the report, and that would be running on a JMS or JCA thread if the JMS provider was a JCA adapter. And then that would potentially either store the results in a database, or it would respond again on another JMS queue with a correlation ID. And in the future, the servlet would, take that identifier, poll the database or poll the queue, and then provide the user with the request updated. So this is one of the problems with early Java EE, and this was incredibly heavyweight architecture just to push an asynchronous break into your application. You need to run a separate JMS broker or use the one internal to the server. There was transactions, two different transactions rolling around. You could potentially, if the servlet was also accessing a database, you could potentially have an XA transaction between the database and the JMS queue. And things really got really heavy. But that was the only thing you could do in the old Java EE before Java EE 7. So with Jakarta Concurrency, what you do now is that you can use what's called a managed executor service. So the managed executor service has the same API as the standard Java SE executor service. So you can submit tasks, you can make groups of tasks. And it uses a thread pool, and that thread pool will typically be managed by the application server itself. Application servers like to manage threads. It doesn't specify that you have to have a thread pool. So it could be that if it's in a different application server, it could just be running through a common thread pool, or you could have an individual thread pool per executor service. But so what you would do is, in the new model, is your request would come in, your REST service or your servlet would basically use the managed executor service, package up the report details, push it onto a separate thread, and then that thread would just basically run separately to your application, which would return and then would run within a set, just on a lightweight thread within the application server. So this model is much more lightweight than running a full JMS broker, obviously, and that provides the capabilities to basically spawn or to use threads asynchronously in the application server without you having to spawn new threads in your code, which would is not good practice within an application server or managed runtime. Because typically the application server wants to control the number of threads it has so that it can manage its workflow. I mean, the purpose of an application server is to manage workloads that are running within the JVM. So just to show the code for something as simple as that, we have, let me bring it up. So we have a basic RESTful web service here. And this is a very simple resource on path concurrency. And what we can do is we can inject a managed executor service. We'll see this schedule one later. And just simply through doing the resource like that, what we'll do is we'll pick up the default. So the specification says there must be a default managed executor service within the application server, and injecting it without a JNDI lookup means that we can just pull in the default one. We could obviously specify JNDI name, lookup name, if we wanted to, because we can deploy multiple different executor services for different usages. You may want to do that if you need to tune your application very specifically. So I have worked on Java application servers, applications where you need to manage which thread pools or which groups of threads are running different services, and you can do that by deploying different managed executive services at different JNDI lookups. Often you need to do that for in highly tuned systems if you're managing race conditions or live locks under heavy load, so that two services will be running on different threads rather than competing for the same small number of threads. And to basically do that simple use case of an asynchronous break, we have a simple job here, and all you would need to do is a similar API to the Java SE executor service API. So you can see you've got submit, callables, runnables, or you've got invoke any, which will which you can submit a whole series of tasks, or invoke all. And basically that piece of code will run this Lambda on a separate thread from the actual server or the RESTful web service request. So we have that deployed into Pyara, if I can find it. So we have a Pyara server running. So I'm running NetBeans here. It has Pyara built into it. We have a Pyara server running, which is not showing anything, but I'm hoping that if I poke simple job, you can see job submitted, and we've got job running, and that's running on a separate thread. So it's returned job submitted, and it executed the Lambda, and the job running came out. Okay, so that's the sort of very simple way of executing asynchronous code within any Jakarta EE application server and application. again, many people don't use this yet because it's not. There's a couple of reasons. One, many people don't use it because it only came in Java E7. So unless you're using Java E7, then you won't have been able to do this. And secondly, which we'll come to later, is Jakarta concurrency isn't in the web profile. So there's no apparent reason why that should be, but it didn't make it into the web profile. So it's only in the full profile application server. Okay. So the second use case for Jakarta concurrency is essentially running multiple tasks in parallel. So obviously we're using managed executor service. It may be, in this use case, for example, if you have an order from a shop, an e-commerce shop, and you need to maybe check, take the credit card payment, also check the stock, and perhaps do other things as well. Set up the delivery, update the CRM, whatever else that you may need to do in the microservices type architecture or in monolithic architecture. Previously, without using Jakarta concurrency, again, people used to send these off on JMS queues and be picked up and executed on separate MDBs. So what you can do now is you can submit a number of tasks in parallel. So this could call the credit card payment, and this could be updating CRM systems to say you placed an order. And then the managed executor service your application can wait until both tasks complete. They will run in parallel on separate threads. They may call out, they could use microprofile REST client API and call out separate microservices and wait for their responses. And again, the managed executor service gives us the capability to do that. So if we look what that looks like in code, so if you go to NetBeans again, I've coded one up. So there's a lot of boilerplate exception handling in here, but effectively what we can do is we can use the same injected managed executor service, and essentially we can submit the job, in this case the Lambda, which is going to sleep for 2 seconds, retrieve the future, and then submit basically a second job, again submit, sleep for 2 seconds, and then we can join the two back together again, by looking at the futures. And obviously the future could have a return value. We could run a callable here, provide a return value, and then check the return values to provide something to the user. So it's pretty simple to do. One of the key things to remember is managed executors will also ensure that all the Java EE context is set up on these new threads. So that's the key goal really for managed executors in Jakarta concurrency. So that when you in this REST request, when you submit this job or this task, this piece of code within the Lambda will be running within the context of the application that called it, even though it's on a separate thread. So that means it will inherit it will know which application you're running in. So it will inherit the application class loader. It could inherit any security principle that was within the application. So if you put authentication or authorization constraints on the RESTful web service, then they would be carried through into the thread. You would retain the JINDI context. So you'd be able to look up application locally scoped resources, for example, data sources, JMS queues if you were going to do that, or any other locally scoped resources. And because of that, you can then also obviously call local EJBs, like I mentioned before, look up CDI beans. And the only thing you got to watch with CDI is the interaction between scopes and on the thread. So this is a little bit unspecified. So to be safe, you would look at application scoped CDI beans would be the safest thing to do. So obviously, because for a request scope bean, it's possible or likely that the request could actually close before your job completes or your task on your separate thread completes, if you weren't going to do wait for the futures. So to be safe, you'd mainly use application scoped CDI beans, and that's an area where we can look at in the future on Jakarta Concurrency to make sure that we can maybe specify that correctly, or maybe this becomes a separate request or whatever. So to see that execute, we can go back here. We have basically a link to get request for the parallel job. It'll wait 2 seconds and then come back. And you can see within the Pyro server log, we can see that we had job 2 running, we had job 1 running, we had job 1 finished, we had job 2 finished. And then we got completed from here, and it should take maybe 1-2 seconds. So they're running in parallel. Okay, so again, spawning, do asynchronous code, spawning threads, or using separate threads within your request is simple. You don't need to go into all the complexity of async methods or any of these sort of things. You can actually use familiar executor services from Java util concurrency, but just with the added the added features of that it supports context propagation from one thread to another in the Java E context, which is very powerful. Okay, so if you go back to the slide, whoa, not that one. So that's basically the second use case, is obviously running tasks in parallel. The other one is periodic requests. So before Java E concurrency, the only way you could really do a periodic job or a periodic task would be to use EJB timers. EJB timers have been around a long time. And you could use the EJB timer service to kick off tasks effectively on a separate thread. But you can also do this now with a managed schedule executor service. This essentially mirrors the Java SE scheduled executor service. So you put a request in, you can spawn off a periodic task, and then that uses the API, can run at set intervals, and that can run periodically. The EJB timer API in Java 7 and above has is much more powerful in that you can schedule cron times. You can use cron syntax to schedule tasks, and obviously Java EJB timers also can be persistent, whereas in this case this wouldn't be a persistent task. And also EJB timers do have cluster semantics defined in their specification, so it does say that a persistent timer will only run on one node in a cluster. But if you just need a simple scheduled task, then you can just use the managed scheduled executor service in the same way as you would use Java SE. Typical way to use it would be either to, if you want it running for the length of your application, to schedule it at the application deploy time. So to do that, you would maybe use a servlet initializer or a CDI listener that listens on the application loaded events, and then you would kick off and submit a task to the scheduled executor service. Or you could do it as an EJB singleton on when it starts up with an startup annotation. But using the code is again very, very simple. So here's a periodic job. I'm going to submit it through again for a REST call, and then it will keep running. So we have injected the managed scheduled executor service. So again, there's a default one of these, and the default one has to be there as part of the specification. So then we can inject directly, or you can create separate executor services for different purposes and put them on a different JNDI name, and you'll be able to use resource lockup to get a different executor service. But if we look at the code, again, it's incredibly simple. So we just basically use the injected schedule executor. Here I just put scheduled at fixed rate. You've got all the standard it mirrors the SE API. So we can schedule a callable. You can use triggers, which is an extension. So a trigger, which I think I've mentioned later, provides business logic for deciding when the callable should be run. So from here you could write, very specific business logic when you create the schedule. You could say it only runs 3 p.m. on a Friday the 13th or something like that. Second, obviously you've also got schedule at fixed rate and schedule with fixed delay, which depend on the different, whether it happens. Basically, this will calculate whether there's latency to make sure that things happen at a certain rate, and these will just be a certain delay after the previous task was run. So it's very simple code. It's not complicated stuff. We can run this in Payara, and it's going to go infinite for a sec here. So if we look at periodic job, we've got one submitted, and then if we go in NetBeans, we'll see this is now going to continually print this out until I shut down the server. Okay, so these are, again, very simple APIs mirroring the SE API. So they're the sort of simple use cases for using a Jakarta concurrency. It's very small API. It mainly just mirrors, I say, the SE API, but there are some other components which are used if you can't use and can't create a managed executor service, because perhaps you may have one already, or you may have to integrate with an API that doesn't use managed executor services but uses normal Java SE ones. So, as I said, the main piece that we've seen is the managed executor and the managed scheduled executor. And these mirror the two Java SE APIs. So, as I said, there is a default instance of each, has a standard JNDI name. You can create additional ones for your specific needs. So, to do that in Payara server, you need to use the administration console. I've got this here. So you would go into the administration console. We have concurrent resources, create a managed executor service, and then, oops, going to log me back in. Do it again. So you just create a new one, and you can specify the JNDI name. There's a whole bunch of other things you can specify. None of these are standard, but these are Payara specific. You can decide, say whether it can support long-running tasks. So these are long ones that the server won't get upset if it lacks for a long time. You can specify hung after, which basically says that if the request takes longer than X number of seconds, then the server will consider this as a hung request, and therefore the server is a little bit in trouble. And then you specify your core number of threads in the thread pool. From Payara, this will end up corresponding to a specific thread pool. And then you've got requests that you can set for the maximum number of threads, the core number of threads, etc. So this is how you would configure this in Payara, but different application servers will have it in different ways. How to do it isn't standardized. The other enhancement, which I haven't shown over a normal executive service, is that within the specification, you can have what are called task listeners. So a task listener is effectively a callback interface, which will show and tell you whether your task is, when it's been submitted, when it's been executed, if it's been aborted. So you can get feedback. So you could therefore monitor the status of various running jobs. So if you submit a whole bunch of jobs, and then you want to create maybe a UI for people to see where they are and what the status is, you could do that with the task listener API. Secondly, I briefly mentioned the trigger interface. When you submit a scheduled job, you can provide an instance of a trigger. And that trigger instance can do some business logic to decide, when this actual job is ready or this task is ready to be scheduled. So there's essentially this very simple interface which basically gives you the time and says, is this ready to go, true or false? And you can obviously then within that call any other Java Jakarta EE service to make that determination, look up databases or whatever you want to do. So these are the ones that we've seen: manage executor, manage scheduled. There is another one called manage thread factory. So this again mirrors the Java SE thread factory, and you would use this for when you need to provide a thread factory to maybe an API that doesn't, that is an SE API or that isn't Java EE aware, and therefore you can't use the executor service. Or you might want to do something. You just want a thread to just fire off and do something quickly, so you don't want to go through a pool or anything like that. You can just submit a thread. So I've got, again, there's some code on there, but I'll show it in NetBeans. So we have one here as an example. So basically going to use a managed thread. I put on here that there's oops, that's down here. There's an executor service, which is a normal SE one. So that's not a Java EE one. That's a standard Java SE executor service. And then we can inject again the managed thread factory. Again, you can, there's thread factory has a default one, and therefore you can just use that directly, or you can create them through the administration console if you need different parameters or different priorities, etc. So this is just going to show that we can use a managed thread factory to basically create threads for an executor that we have no control over as just standard Java SE. So here we just check whether this executor service has been created. If it hasn't, we create it. And then we submit again. This is a lambda of a runnable. And it's just going to print out what my current thread is. And again, what the managed thread pool does is when it creates a thread for the SE API, it will ensure that thread is set up in a way that it can inherit the required Java EE contexts. So again, it will inherit the security, the class loading, the JNDI, namespaces, all those things that you need, the bean managers, etc., so that you can then run standard Java Jakarta EE code within the submitted task. So if we run this within Pyara, so we have a managed thread that submitted it, and we've got periodic jobs still running, but we can see that this bit of code ran a separate thread, and this is the name of the thread. Concurrent _/ default minus thread factory is the JNDI name of the standard thread factory. Okay. And if we run it again, you can see that it's created thread 2. So it's creating new threads on demand, and they are separate, obviously, to the one that's executing the service. But you would be able to call any Java EE code within that. Okay. So that really is used for integration. So, anything that executors in the SE world can take a thread factory as a parameter. So anything that needs an executor or any API that requires you to pass in one, then you could create one, a standard one with a managed thread factory. The next standard class really in the specification is the context service. So the context service is a little bit more complicated and probably a little bit more esoteric in its usage, I suppose. So what it is when you need an object to run in a Java EE context, but you've got an unmanaged thread. So that's one that hasn't come from a managed executive service or a managed thread factory. And what it does is effectively, when you create it, it captures the context of the Java EE application at that point in time, and then when you use the proxy, it will re-establish the context. It's probably easy to see in the code. but it allows you to capture context. And because the context has to be serializable, it allows you to pass context about. So I've seen this sort of thing used in security, whereby people need to capture the authenticated user or the principal that's on the Java or Jakarta thread, and they need to pass that around, and they need to reestablish it when something is executed on a different thread. So for example, here we are creating a standard Java SE runnable. We are creating a standard Java SE thread and starting it. And what we're going to do is to make this capture the context. What you do is you use the context service, which has been injected here, and you create a contextual proxy. And what that is it's basically going to create a reflecting proxy using the normal proxy API, and that's the instance that you're going to wrap, and that's the interface that the proxy has to inherit. Okay, so when this thread basically calls run on this runnable, the context service will establish, or the proxy will establish the correct context which will have inherited, so the security, the JNJ namespace, the class loader, etc., and then run this method within that context. So it's much more complex, but it is very powerful. So if we just go back to the runnable proxy, you can see we started a new thread, and this will spit out that it had run in the context. So again, these are where you just need to submit a object, if you like, to a thread that you don't control, and you need to capture the context and then run it in a new, basically reestablish that context before you execute the method. So that's one of the 4 main services that are currently in Jakarta Concurrency, or Java EE Concurrency utils as was. So that's how you would use it. It's, like I say, it's a pretty small API. There's not many classes in there, but it hasn't changed since Java EE 7. So what do we want to do for, say, Jakarta EE 9, Jakarta EE 10? So these are just some ideas. So these are all now open to the community. These ideas have been culled predominantly from the GitHub issues. So if you've got any ideas, or you use concurrency and you want to see how it, you want to see how it changes, or you want to change it, then this is, so the project is where you need to raise those questions and those issues. So I'm going to go through a few. We don't have code because obviously this doesn't exist yet. So the first one is deployable managed objects. So currently, to create a managed object, which is when I talk about managed objects, I'm talking about a managed executor service, a managed thread factory, a managed scheduled executor service. Currently, the only way to do that in Payara, and probably in most other application servers, is to do it through the administration console. So you can see here, you can create them through the admin console. But obviously, as we move to more lightweight runtimes like Payara Micro, where we don't have an administration console, or we're running a single application, then that has limitations in that you would need an administrator to set that up. So what we're suggesting is, just like you can now do data source definitions and deploy a data source and connection pool along with your application as an application scope resource, then we should be able to do that with these managed objects as well. So this would allow you, if you create an application, you would be able to, just like with data source definitions, specify on one of your beans that you put this annotation, and this would then create a managed executor definition on deployment time, give it a JNDI name, tell it which context service you wanted to use. So again, you could package that in your application. You could specify the max concurrency and min concurrency, So we would avoid sort of thread pool semantics, because some application servers don't, create separate thread pools for these things. And that would also then allow you to control your concurrency pretty closely within the application. You could have different thread pools for doing different things, or different thread groups for doing different things, which, like I said, you often need to do in quite high load or highly tuned systems to prevent deadlocks or live locks or that sort of thing. So that's one thing that we think would be quite easy to do. Obviously, there's already the capability in all the products to actually create these things through administration consoles. So parsing an annotation to deploy one should be pretty simple. And we'll be able to add properties and things to do, application server specific. This would be very useful in the Payara Micro situation. So Payara Micro is a web profile plus extras version of Payara, which is just in command line. So I've got here, this is quite difficult to see because it's probably underneath your pictures of my face. It says Java -jar Payara micro.jar. So Payara micro just runs as a straight jar file, and then you tell it to deploy a war. And then that would run exactly the same application that we've got now, which I won't show, but because of its model where you just give it a WAR file to run, you would typically run this within a Docker container. You don't really have an ability to create these managed objects on the fly, although Payara Micro does provide a way to do that through command lines, but it's a bit clunky. It'd be much better to do this through deployment within your application. That's the best way to do data sources in Payara Micro. For example, you put the data source definitions on an object like an EGB or an application scope CDI bean, and it will deploy the data source for you without having to create pre-boot scripts and post-boot scripts. So, for example, that deployed, and then you've got our different web services there. So, deployable managed objects would be powerful. And allow you to do quite a lot of concurrency control and thread pool creation within your deployed application. The other thing we're thinking about is a schedule annotation. So like I say, at the moment, all you can do is use the manage schedule executor API directly, or you can create EGB timer annotations for EGBs that will give you a schedule. But why can't we just do that for CDI beans? So that's how this would look. Here we have a application scope CDI bean. We had a schedule annotation. Potentially we could have give it a logical executor name, so you could then also deploy which group of threads that you want this to run on. And then similar to the old EGB timers API, we could have a cron-like syntax to actually show and tell it to run every 5 minutes, for instance. And this could also potentially support persistence. Otherwise, although that would expand the API to ensure that you had a persistence layer too. But given that application servers or managed runtimes like Payara Micro have to support persistent timers, then this is already there. We could define what the cluster semantics of this are. We could add cluster semantics to it. We could have singleton, which says it only runs on one node in the cluster, or we could say on all cluster nodes, or whatever we decide. We think that would be quite powerful. It's very similar to, I believe that there's something similar in Spring that you can do this on. So that would just bring that into Jakarta E. Again, pretty trivial thing to do. It's just going to be submit that object into a scheduled executor. Next one is async annotation or asynchronous. We could then, the logical place for an asynchronous annotation is within the concurrency specification. We could just put an async. Again, the annotation could specify which executor to use, so you've got a lot of control over which thread pools, etc., or thread groups that you want to run the method on. and then you could support a method signature that returned a future. And this would again, provide very simple async functionality into CDI. And the foundation of other async, APIs within the whole platform spec could be based off something like this. Okay. And then there's another piece of work that needs to be done. We need to catch it with Java util concurrent. So Java util concurrent moved on. And as Jakarta Concurrency is effectively an implementation of Jakarta SE, it was built on top of Jakarta SE concurrency, along with the managed threads. Then there's certain areas that we need to do just to bring the spec up to scratch with what's in Java SE 9 and 8. So the first one that's been suggested is obviously we need to support the fork join pool in a standard way, and therefore we could create managed fork join pools, and this would allow us to create to use streams in a managed way. And so when I say managed, I mean have all the context of Java EE, so the security principle, the class loading, the JNDI namespace, and all those other things that you'd expect in the Bean manager. So we could potentially do this now, then in that you can get around this. You create a fork join pool with a specific executor implementation, which you could pass in a managed executor because it implements a SE executor interface. So you could do that, but it'd be good to have a way to do that as a standard that across other application servers, which doesn't necessarily mean it needs to be programmatic. So we could, deploy these or configure it in a way that it's fairly transparent. Again, Flow came in Java 9 to bring a reactive-like API into Java 9 and beyond. So we need to work out how we would integrate that so that we could use Flow in a way that managed objects can be incorporated. So we can create the right threads, we can create the right context, and we could, within the subscribers and publishers, you'd be able to use Java Jakarta EE objects. The other one obviously is currently the API is future-based, so we need to support completable future. There's a couple of ways we could do that. We could add the API onto the managed executor, so we could have a run async and a supply async API and managed executors, or we could create effectively a corresponding class which is a managed computable future. So those things all need discussing and standardizing, but once we've done that, we'll catch up predominantly with Java util concurrent. And then there's some alignment with microprofile. So microprofile has created microprofile context propagation, which was basically created to some extent as a response to the fact that Jakarta EE concurrency wasn't off the ground. So we could align with that. We could either re-standardize it, but that effectively is bringing in the APIs for completable futures, and also has a more sort of powerful context capture API, and has more well-defined semantics of how CDI beans interoperate with context propagation in the microprofile. So that needs looking at, and look at how we align that or potentially re-implement that into Jakarta EE. Finally, there's some general platform alignment that needs to be done. Like say the specification is a bit loose on how Jakarta concurrency would interact with context and dependency injection. And microprofile context propagation has gone much further on this, so we can look at that. I'd like to see this brought into the web profile, because there's no reason that it isn't. There's nothing that it depends on that isn't in web profile. And for Pyromicro, which is ostensibly mainly web profile APIs, it was too useful an API to leave out. So Pyromicro supports Jakarta Concurrency. And that then obviously then brings, thread management into web profile implementations. We could go a bit further. We could re-implement Jakarta Enterprise Beans asynchronous on the concurrency API. We could either create a new async annotation and allow that to be used as an alternative to the Enterprise Beans one, or we could potentially modify the Enterprise Beans one to allow a named managed executor service to be specified to be used as the thread pool. So that would achieve the same effect. But I'm quite like trying to align these things onto this single APIs rather than getting the wrong import for the wrong asynchronous annotation. Got a bit further and maybe a bit more radical. You could potentially re-implement Enterprise Bean timers onto the concurrency. That would require a new schedule annotation, and then that annotation could be used with both EJBs or Enterprise Beans and CDI managed beans. Alternatively, again, we could potentially put on the timer annotation, the current one, which managed executor service to be specified, maybe in either JNDI name or a logical name. And then again, further one is async servlets and JAX-RS. We could again implement them on top of Jakarta Concurrency. Simplest way is just to allow them to take a parameter, which is a logical executor name, and then ensure that if that name is set, then it uses that executor to implement, as the thread source or the asynchronous source. Finally, there's some little bit of cleanup that needs to be done on the actual API as it currently stands, and some evolution or some little enhancements we could do that would make it more powerful. Obviously, this came in Java 7, and there was no changes to Java 8, so there's no date and time support in the APIs, so the APIs could be modified. So trigger in particular and last execution use dates. They could be moved to or added methods for date and time support. We could provide some concrete trigger classes. So as I said, a trigger can use your own business logic to define when the message, when a scheduled task is due to be fired. We could create a cron trigger. Spring has this. It's even mirrors the trigger API from Jakarta Concurrency, so we could easily create one of that for somebody. And then again, some of the deployable managed objects, the configuration attributes aren't standardized. They're just examples within the specification. We could standardize some, like max concurrency, min concurrency, priority, some things like that, if everyone agrees what that set is. So how to get involved? So as I said, these are all ideas culled from the GitHub issues. So the Eclipse project is there, the URL's there. All these live stream presentations are all recorded, so you'll be able to see this. There's a mailing list where we can discuss concurrency utils. Anyone can register. Jakarta is all open source now, so everybody can get involved, no expert groups. I'm no expert and I'm project lead. So if you want to raise features that you want, go into GitHub, just raise a normal GitHub issue like you would anything else, and then it'll get discussed. There is a Eclipse project which does an incompatible implementation, which is the version and implementation of concurrency utils that's embedded in Glassfish and both Payara and perhaps others. Remember, we're now in Jakarta world, so this is now code first open source development. If we want to create these annotations, then we can start messing around with them straight away on the projects. So thank you. I think I have 5 minutes left, so I shall try and see if I can answer any questions. It's going to go freaky on me though, I think. So I might stop sharing my screen, and then there we go. Okay, we got two. So both from Reza. Where do we need more community contribution most? To take that one first. Everywhere, I think. We have a set of, like I said, those ideas we have there is a set of work, and we can start that now. But I'm definitely not the font of all ideas, and neither the rest of the project team. So if anyone has anything burning, then first thing to do, I would say, is to raise an issue on GitHub issue tracker, and we can track those. And the new feature requests. Even though it used the word issue, you can add new feature requests. And then alignment with microprofile, I sort of touched on that. I think microprofile has done some good work, and mainly because of the slowness in the Jakarta EE transition, I think we can take a lot of that work and look to implement that potentially within Jakarta EE, either in the Jakarta namespace or in another way. There's also work done in microprofile reactive streams, which is a bit more hardcore. If that came over to Jakarta EE, the question is really whether that would go in concurrency or in its own API, or whether it's going to end up in Java SE anyway. So, but those needs looking at. Okay.
Okay, so yeah, Steve, that was amazing. Thank you so much.
No problem.
I think we're now getting ready for the next session. And we will let Steve go, and we'll talk to you in a bit on the panel again. So we truly appreciate you being here.
No problem.
And I will end this session and invite everyone to the next one. See you there.
All right. Cheers. Thanks.
Bye, Steve. Bye, everyone.